example on integer multiplication. See, before watching this video, you should watch the immediately previous example, because we are going to multiply these two numbers using the technique that we applied in the previous example. Okay. We will get an incorrect answer, then we will see why we are getting an incorrect answer, then we will correct the method, and then we will come to the correct answer. Okay. So the line of action is like this. Example 1 is quite important. So watch example 1 before watching this particular example. Now, what is the difference between first example and this example? In the previous example, we multiplied 0, 1, 1, 1 with 0, 1, 0, 1. So here the multiplier was equal to 7 and the multiplicand was 7 and the multiplier was equal to 5. Both of them were positive and the result we also got positive. But in this example, the value of multiplicand is equal to minus 8 plus 1, that is minus 7, and the multiplier is still positive, that is 5. And minus 7 multiplied by 5, we know that the result should be equal to minus 35. Okay. And the representation as before, we are using 2's complement representation. So see what will be the problem here. Why do we get an incorrect answer? So let us first of all multiply as we did in the previous example. 1 0 0 1 into 1 is 1 0 0 1. Then 1 0 0 1 multiplied by 0 will be 0 0 0 0. Then 1 0 0 1 into 1 is 1 0 0 1. And finally 1 0 0 1 into 0 is 0 0 0 0. Again 4 bit multiplied by 4 bit equal to 8 bit result we want, and that's why the last row is 7 bit. I will add an extra bit 0. Okay, everywhere we will add zeros and we will then do the final addition. So 0 0 0 0 0 0 0 0 0, and let's add 1 0 0 0. Cross should be treated as zeros. Okay, then 1 plus 0 plus 0 plus 0 is 1, 0 0 0 0 is 0, 0 0 1 0 is 1, 1 0 0 0 is 1, all zeros 0, 0 0 1 0 is 1, 0 0 0 0 is 0, 0 0 0 0 is equal to 0. Okay, and you can see that the result is coming out to be a positive number, and we know that minus 7 multiplied by 5 should come out to be equal to minus 35, which is a negative number. Okay, and let's see what value we are getting in this particular case. So the value is 63 minus 32. Okay, let us do it like this. What I will do, 1 0 1 1 is 11 multiplied by 4 is 44 plus 1, the value is coming out to be equal to 45. Okay, you can check 32 plus 8 plus 5 will come out to be equal to 45, and it is plus 45. The correct answer is minus 35. So we are getting an incorrect answer. Now here we did the exactly same thing that we did in the previous example, that multiplying, then fill in the remaining places. These are the remaining places that we are filling with 0. Okay, so padding we are doing with 0, and then we are adding, we are getting incorrect answer. So you need to think over this, why we are getting an incorrect answer. So first of all, before directly jumping to the correct answer, let's analyze what is getting wrong. And before doing the analysis, what I am going to do, we will expand both multiplier as well as multiplicand. So this 1 0 0 1, let us see what does that 1 0 0 1 means. Here the place values are 1, 2, 4 and minus 8, and therefore what we are doing here, we are multiplying minus 8 plus 1 with, here the place values are 1, 2, 4. Okay, so this 1 represents 4 and this 1 represents 1. So what I can say, okay, let me do it like this. Here the multiplicand is equal to minus 8 plus 1 and the multiplier is equal to 4 plus 1. And therefore what you are doing, you are multiplying minus 8 plus 1 with 4 plus 1. Okay, therefore you need to multiply minus 8 plus 1 with 4 plus, okay, let's solve minus 8 plus 1. Minus 8 plus 1 is equal to minus 7. Okay, so minus 7 multiplied by, okay, m multiplied by q is equal to minus 7 multiplied by q is equal to 4 plus 1 is equal to minus 7 multiplied by 4 plus minus 7 multiplied by 1. Now minus 7 multiplied by 4 should be equal to minus 28 and minus 7 multiplied by 1 should be equal to minus 7. Or we can do in more detail like this. Here we will take all place values. Okay. So it is like 0 plus 4 plus 0 plus 1. Okay. Because these two bits are 0. So the Q we will take 0 plus 4 plus 0 plus 1 which is equal to 5. And now I will expand this. So M multiplied by Q, M is equal to minus 7 multiplied by Q is equal to 0 plus 4 plus 0 plus 1 equal to minus 7 multiplied by 0, okay, plus minus 7 multiplied by minus 4 plus minus 7 multiplied by 0 plus minus 7 multiplied by 1. Now if you consider the individual terms, it comes out to be equal to minus 7 into 0 is minus 7 plus minus 7 into minus 4, sorry, not minus 4, this is minus 7 into 4, minus 7 into 4 is minus 28 plus minus 7 into 0 is again equal to 0, this 0, minus 7 into 0 is 0, okay, minus 7 into 0, 0, minus 7 into 4, minus 28, minus 7 into 0, 0, plus minus 7 into 1 will be equal to minus 7, and this is how we are going to add. So here comes the basic problem. See what we should be adding, we should be adding 0 plus minus 28 plus 0 plus minus 7, and what we are adding here, we are doing something entirely different. Okay, so this 0 0 0 0 1 0 0 1. Okay, now you should treat the entire row as a 2's complement number and you should get its value. Now here the sign bit is equal to 0. See what I am saying, we have got 1 2 3 4 5 6 7 8 bits in every row. You treat entire row as one single 2's complement number. So here the sign is 0, that means it is plus 1 0 0 1 means 9. Okay, so this row is completely 0. This row is 0 0 1 0 0 1. So 9 into 4, this is equal to 36, and here again we are getting 0, and therefore 36 plus 9 comes out to be equal to 45, and that's why the result is coming out to be equal to 45. So what is the important problem here, that instead of doing, okay, here the least significant part comes first, so I will write down the same multiplication as minus 7 plus 0 plus minus 28 plus 0. Instead of adding minus 7, 0, minus 28 and 0, we are adding 9, 0, 36, 0, and that's why the result comes out to be equal to 45. Okay, and now let's expand further. What is the problem? Now minus 7 is represented as 1001. Okay, but it is 4 bits. We want to add in 8 bits. So for converting these 4 bits into 8 bits, you should apply the concept of sign extension. You need to add 4 more bits, and that those 4 more bits will be the original sign bit, and that's why this minus 7 should be written as, okay, I will write it down like this, minus 7, 0, minus 28 and again 0. Okay, now this minus 7 is 1001, but we want 8 bit, so you apply the concept of sign extension. So take 1 1 1 1, 0 should be 0, minus 28. Okay, now how would you write down 28, 16, okay, minus 28 can be written as 1 2 4 8 16 32, 32, we will go for minus 32 plus 4. So I will make this 1 0 0 0 0. Okay, this number is minus 28. Again let's verify, minus 32 plus 4 is equal to minus 28, but we want 8 bit, so I will apply the concept of sign extension, and then 0 will be taken as 0. And now you compare this pattern with the pattern that we are having. Okay, now 1001, we have got this 1001, then 0000, we have got 0000, this is correct. Fourth row is also correct, we have got all zeros. Now this third row, we have got 100100, see 100100, but instead of taking this 11, we are taking 00, and similarly here we have got this 1001, but instead of taking these 4 ones, we are applying 4 zeros, we are adding 4 zeros, and that means what is the mistake that we did while doing this multiplication is that when we were about to fill the remaining places, we blindly added zeros. You should never blindly add zeros. Instead, you should apply the concept of sign extension. So if it is 0, add 0. If it is 1, add 1s. And therefore, the correct way to do this multiplication would be based upon this. See, this 1001, if I add zeros, it will become wrong. It will become like that. Because 1001 is minus 9. And if you add 4 zeros like this, then it will get converted to plus 9. Oh, sorry, minus 7, 1001 minus 7. When you add 4 zeros, will get converted to plus 9. However, if you add 8 times 4 ones, then minus 7 will remain minus 7. See, the problem is, I will magnify the problem further. The problem is like this. Let me write it down here. 1001 means minus 7. If you add 4 zeros to the right, then the value becomes plus 9, because the sign bit here is equal to 0, which means positive number. But when you add 1111, then the value still remains equal to minus 7. And therefore, if you want to convert 4 bit minus 7 into 8 bit minus 7, then you should not add zeros, you should instead add ones. And that is the important mistake that we are committing here. So, what I would suggest, you note down this part, everything which is there on the board, and then we will see how to do the correct multiplication. Okay. So, pause the video at this time, note down all these things which are there on the board, and then continue the video. So, let us see what is the correct way now. It will be like this: 1001 multiplied by 0101 minus 7 multiplied by 5. So, first of all, 1001 into 1 is 1001. Okay. See, it's like minus 7 into 1 is equal to minus 7. Then minus 7 into 0 will be equal to 0. Then minus 7 into this is 4. Okay. 1, 2, 4. Minus 7 into 4 should be equal to minus 28. So, what we will do? We will write down 1, 0, 0, 1 and shift it with 2 places. So, 1001 means minus 7. Add 2 zeros to the right. It will get multiplied by 2 square. It will get multiplied by 4. And minus 7 will become minus 28. And then 1001 multiplied by 0 is equal to again 0. So, this will be 0, 0, 0, 0. And now what I will do, I will write down all the values in binary using 2's complement notation. So, 1001, 1, 2, 4, minus 8. Minus 8 plus 1 is minus 7. All zeros, 0. 1, 2, 4, 8, 16, minus 32. Minus 32 plus 4 is equal to minus 28, and all zeros will be equal to 0. And minus 28 plus minus 27, minus 28 plus minus 7 comes out to be equal to minus 35. And now here we want the result in 8 bits. That's why we are going to convert all rows in 8 bits with sign extension. So here the last bit is 0, so I will extend 0. Here the last bit is 1, so we will extend 1. Here last bit is 0, so we will extend 0. And here the sign bit is equal to 1, so we will extend 1. And now you add, keep 8 bits. If there is any 9th bit, discard it, you will get the correct answer. 1001 is equal to 1. 0000 is equal to 0. Okay. Then 0010 is equal to 1. 1000 is again 1. 1000 is again 1. 11 is 0 with carry 1. 111 is 1 with carry 1, and 111 is 1 with carry 1. We will discard that extra carry. Okay. So 110 111 01 is the answer that we are getting. Now, in order to convert this particular value in decimal, you take again the 2's complement. So for that we will take first 1's complement, which will be 0 0 1 0 0 0 1 0 and then plus 1. Okay, 1's complement plus 1 will be equal to 2's complement. It will be 0 0 1 0 0 0 1 0 plus 1 will be equal to 1 1, and 1 2 4 8 16 32 32 plus 2 plus 1 is equal to 35, and this is how you should get the correct result. So what is the conclusion? While taking, conclusion is, while expanding to 8 bits, you should expand using the concept of sign extension so that you get the correct answer. Okay. So what I would suggest you take this bit pattern, do the multiplication yourself. First of all, do incorrect multiplication, then do correct multiplication, write down all the row values when you expand with 0 and when you expand with sign extension, and then work out. You need to practice all these things. I have told you everything that needs to be told. This is only the second example. We will be seeing 2 more examples. But if you want to get the most out of this thing, then before going to the next example, you should work out these examples yourself. We are in no hurry. Okay, there is no hurry. Rather than running through all the videos, you should make these 2 examples very clear before we jump to the third example. Third example, again we will do the same thing. What we learned from the example 1 and example 2, that we will apply in example 3, but again we are going to get an incorrect answer, and then again we will correct itself. This is how I teach. First, let's do the mistakes that occur, and let's then correct ourselves. Let's see where did we go wrong, and let's correct ourselves and learn. Okay, so the topic evolves. You do something, you learn something, you again make mistake, you again learn something, again make mistake, again learn something. Okay, so that's the beauty of learning from your own mistakes. So doing mistakes is good. Okay, particularly if it is not on the day of exam. Thanks.